everyone. Can you hear me well? I could not fall asleep last night. I was so excited about talking tonight. And I found it very funny that I'm going to talk about stress and I'm stressed. And it's very interesting to know what you're feeling actually inside when you feel this way. So for example, I'm not get used to speaking with so many people at the same time. So I feel heartbeat going on. And interestingly, I recalled, and I put it on the next slide, that when I was an undergraduate, just like you, I used to skydive a lot. And every time that I feel the heartbeat, it feels very familiar because I see familiar faces of my friends, my little brother, my future husband, and the door, and how we would go this skydive together. Oh, okay. Those are faces. Those are skydives. So what gets me very interested is why we remember things we remember, especially those which are emotionally charged. I'm sure every single person in this room can recall some sort of event which you remember very well in every single detail. And it's probably some sort of emotion is associated with it. Now let me run a little bit of what I'm trying to squeeze into in today's talk. I'll go over crickets, and you'll find out why it is so important. Crickets are important. Brain morphology. Then I'll talk about reward system, stress, depression. I found that drugs is a good place to put after depression, and a natural high. And I hope I have enough time to go over natural high, since it's the best part. So crickets. Many years ago in China, and still now, there are cricket fights. And Chinese people bet huge money on those fights. And if you try to Google cricket fights, you'll find something like this. Very surprising. But let's go back to, so it's not something human and cricket share, but you can see. So crickets. If the cricket loses a battle, it refuses to fight anymore. And what Chinese owners of the crickets found, if you threw cricket in the air and let them fly, cricket is ready to fight. One more time. It's like it's forgetting its past memory of the lost. So I decided to go back to the slide which I closed my previous talk a year ago about consolidations of the memories and how they could be interrupted. Let's see if yes. So consolidation happens somewhere here. And it's about 10 minutes after emotional event took place. For cricket, for human. I was a high school student. And obviously, I didn't know about crickets, and I didn't know anything about neurobiology. But I would have a part-time job on a staple, working with horses and training young kids and adults how to ride horses. And the only thing we knew for sure, if a person falls off the horse, the best thing you can do for this person is to put them back on the horse, and the earlier the better. Now, studying neuroscience, I know exactly why it's happening. We are interrupting the pattern of formation of painful memory. I remember pretty well myself climbing on that stupid horse and wiping tears with my sleeve because I knew if I don't climb on that horse right now, next day, that will be much harder. So we all have stuff happens to our life. But remembering this stuff is optional. Next time you have something you really don't want to remember, remember you still have 10 minutes. Now, that's a result of my master's thesis. Don't be too scared, but I wanted to show it to you because this is how brain pathways work. It's complicated. And I'll try to make tonight's talk a little bit easier. and a little bit more engaging. But for now, I want you to pay attention to those two. This is ants' brain, or crickets. It's not even human, but they do have dopamine. How many of you knows what's dopamine? Hormone of happiness, and ants have it. There must be a reason why everybody here who has brain pretty much has a dopamine. Octopamine is similar to other stimulants like cortisol and human, but has a different nature there. But I want to point out, when those two are high, the stimulus get recorded into emotional memories in crickets, in ants, in human. Human brain is a little bit more complicated than ants, but I want you to show what I'm going to focus on today. That's a little part where our emotions are stored, those guys. And it lies on, I think this part is a little better. It lies on a hippocampus area of the brain. It's right in the middle. It's a very old area of the brain. And hippocampus is responsible for memory formation. It consolidates more memories. So it's very interesting if you see morphology that emotions are sitting on top of the memory formation unit. And they will be involved into processing information all the time. So what kind of emotions are recorded? All kinds. Amygdala actually doesn't make a difference between sad emotions, negative or positive. It's all getting recorded. As far as it's an emotion, the events will be recorded. I will start with my favorite, dopamine, and the reward system. I cannot emphasize much how much dopamine means for us, how much it means for animals in general. It requires for focus, motivation, all the excitement, all the pleasure comes from dopamine. If you recall anything you like, enjoy doing, it will probably have some dopamine boost in it. Let's see. Okay, right now you want to pay attention to the slide, because the next slide will have something which will change your life forever. Everybody's ready? So, good. What I just did, if you now go back to your brain and check out your brain, you just got a boost of dopamine. Dopamine tells you something important is going on, pay attention. So pay attention is a boost of dopamine. Dopamine does a lot of things, including activation of your memory. And placing a picture of something emotional on the slide always helps to bring up some emotions out too. So I did it. Feel free to do it too. The interesting thing is that I got your attention for 10 seconds. That's about the attention span of average human being. If I don't maintain your interest, later I will lose your attention. So it's normal to have attention for 10 seconds. And it's important for you too to know that if you're getting tired and bored, it's not because you're bad or anything. It's just because your nature. You can pay attention for 10 seconds. And then you need another boost of Trump. Okay, let me ask you this. I'd like to shift to cortisol now. How many of you know what's cortisol, kind of? Let's see. Little less than dopamine, huh? Good. Second question. Those who know what cortisol is, do you think it's good for you or bad for you? Let's say, who think it's good? Okay, 10 people. Who think it's bad? More people. Okay, I have to tell you, it was a trick question. Cortisol, first of all, it's important. You can't live without cortisol. When you have your coffee in the morning, you rise your cortisol level. It helps you wake up. Without cortisol, you can't wake up. Once your alarm goes on, your cortisol level starts going up. So if you feel stress, I do not encourage drinking coffee. It raises cortisol, but it helps you to wake up. Additionally, cortisol helps you to perform on tests, any kind of test, even if it's a driving test. And obviously some activities, I think you can see my brother right there, which requires a lot of attention and focus, also increased with cortisol. So in a way, cortisol is kind of reminds us dopamine, but it's a completely different system of activation. So what's the problem with cortisol? There is a problem with it. Let's see. This is how, in general, things work. So let's take an example. Car accident, right? You're moving very fast, you see something on your way, you push on the brakes. You push on the brakes very quickly. So how do you push on the brakes? The sense comes here, and it skips the whole thinking process. It goes through amygdala, and decision is made directly without involving you thinking about it. So what is done is adrenaline is released, and the brake is pushed without you thinking about what's going on. Even though it's quite far from the brain, this is the kidneys, and this is adrenal gland. But it senses the signal from the brain within seconds. So let's see what's going on here. Once danger approaches, amygdala is involved first. Amygdala is what gives you the first response. For example, we are afraid of snakes without thinking about it. It's in our DNA to be afraid of snakes. That's amygdala. Then it sends signals to hypothalamus, and then it's a release of multiple different hormones, which I don't want to go into details unless you want to be a neuropsychiatrist or just interested. If you are interested, you should look it up, because for me, it's fascinating. I just wanted to show you how many players are involved into the fact of pushing brakes. You think you just push the brakes, but you actually activated multiple regions of your brain, including your adrenal gland. And that adrenal gland releases multiple hormones: adrenaline, noradrenaline, and cortisol. Cortisol comes later. So when you push on the brakes, you usually are fine. But within a minute, you might experience shaking. So people get scared after the accident. Usually minutes after you experience actual, real stress. That's cortisol. Cortisol is harder to produce and release into the brain, so it takes a little bit of time to make it. That's why it takes longer. So, surprise, surprise, it's involved in the memory formation just as well as dopamine, both adrenaline and cortisol. Adrenaline cannot cross blood and brain barrier, so it stays within the blood. So how would you think adrenaline can affect memories? It can affect memories very well. It causes blood sugar goes up significantly. And interestingly, the older the person, the less blood sugar is rising, which some scientists think that's why their memory impairs. But the case is that the sugar helps increase the memory, and cortisol goes through the brain and activates amygdala. Amygdala starts recording all the surroundings. So if there is a clown, it will be recorded as a danger. So interesting things happening here. So I have two graphs. One is a peak of adrenaline and performance on rats. And this is stress in general. What I'm trying to show you that we're doing very well if the stress is moderate and short. If the stress lasts too long or it's too much, our performance is going down. And performance is also a memory too. So sometimes, for example, if stress is exceeding certain thresholds, person actually completely forgets the events of the day. So they have a blackout. They don't remember anything if the stress was too high. That's because of this. it's okay. It's another lecture. But what I want to tell you here, that my next slide doesn't have anything to do with neurobiology. It's actually my husband's favorite slide. Not because of the surfer, but because of the flow channel. He's into being effective and time management and everything. So the point here is that people should stay within this flow channel. On one side is an anxiety when you are stressed, and the other one is a boredom. And what's going on is if your skills are too high, you're bored. And if your skill is too low and the challenge is high, you are scared. For example, if you're not prepared but you have to give a presentation, you are here. And if you have to talk to 5 years old about neuroscience, you're here. So what you like to do, you want to stay in the flow channel. So since your skill level will always go up, you always have to increase your challenge. And once you stop doing it, it's getting sad. So, do most of you stay in the flow most of the time? Don't be afraid. You are joining the majority right now. So, just bringing up your attention back. I wanted to shift to the issue of depression in the United States and in general in the world. So 1 out of 8 people in the United States currently taking antidepressant. And when I went into those numbers, I got interested, what's going on really? Because they were discovered 50 years ago, it's not that long time. Why is it so popular? I also have a little bit more statistics for you here. So United States is doing great. We're at the top. Or the bottom, it depends how you look at it. That's the amount of people who need help. And what's very interesting here, that 60 people who is taking antidepressant is doing it for at least 2 years. That means it's not some sort of a pill you take and you get healthy. They kind of stay in that state, which means that antidepressant not necessarily treating the issue. So I decided to dig deeper into this, and I'm going to show you this. And you probably look at it, and I don't know. Fine. It took me about 2 hours to figure out this network, so I'm not going to even try to explain it, but I did a simplified version for you. The point of a previous network is antidepressants affect serotonin level and noradrenaline level. So it's counteract depression and increase neuroplasticity in the brain. I will get back to neuroplasticity at the end of my lecture to show you that neuroplasticity is when your brain grows. If it doesn't grow, it degrades. There is 2 stages. It either degrades or grows. So you want to stay in the growth phase all the time. So if a person is taking antidepressants, then serotonin will go up. And here is another visual, how things happening. So that's a healthy person, and then something happened, and the amount of serotonin is going lower. Low serotonin, sad person. Then if you take antidepressants, they block, most of the time, reuptake channels, those which take serotonin out. If you block it, serotonin stays in for a longer time, and symptoms of depression is eliminated. Symptoms is eliminated. So the person feels good again while they're taking antidepressant. Now I want to talk about other kind of drugs as well. Hope you like it. And there are many. Absolutely amazing how many drugs are out there. I took a look at some of them, and while being an undergraduate just like you, I decided to see how drugs work, not on myself, but on the brain of some other people. I'm going to show you some. interesting games. So most of them either affect dopamine system, reward system, you probably heard about it. That's why they're so addictive. And the others affect serotonin level. So if you look at the list, you probably can identify some of them. They are familiar to everybody. No, you don't necessarily take it, but you heard about them. So what I want to do now, I want you to join a mouse party for a second. And it's my favorite source to explain drug effect on the brain. And if you have time afterwards, I encourage you to go. Got a marijuana one. Okay, let's do that.
Before marijuana enters the system, inhibitory neurotransmitters are active in the synapse. These neurotransmitters inhibit dopamine from being released. When activated by the body's own native cannabinoid, called anandamide, cannabinoid receptors turn off the release of inhibitory neurotransmitters. Without inhibition, dopamine can be released.
So before I move on, I just want to emphasize your attention right here. That's a natural internal signal. And when we start talking about exercise, I'll get back to that place right here.
THC, the active chemical in marijuana, mimics anandamide and binds to cannabinoid receptors. Inhibition is turned off and dopamine is allowed to squirt into the synapse. Anandamide is known to be involved in removing unnecessary short-term memories. It is also responsible for slowing down movement, making us feel relaxed and calm. Unlike THC, anandamide breaks down very quickly in the body. That explains why anandamide doesn't produce a perpetual natural high.
So just she said that marijuana compound is very stable over time compared to what we have in our body. It stays longer and is activated for a longer time. Okay, I think we can return the mouse now. So on your time, go online, Google mouse party, and check out all the rest of the mouse. I highly recommend. Okay. I need to close this. Okay. How about this? Okay. Little bit live. Just to summarize, what's going on here is, I'm going to put those pictures sometime. So what's going on with the drug is it creates a situation when we have so much of a good thing, much more than normal. So that's food or sex. That's a normal stage. Cocaine and other drugs can produce effect which almost 10 times stronger. And what it leads to the fact that receptors can't handle so much anymore, and they get desensitized. I probably misspelled it. They're not sensitive to serotonin anymore, or dopamine. Neurons also get tired, and you need higher doses to maintain the same level of high. And it doesn't happen with a natural one. Why I put donuts here? What do you think? Donuts are not found in nature. It's a perfect drug. I just had a dozen donuts yesterday in Stockholm. It's a perfect drug. It's a combination of oil, sugar, and hydrocarbide. It activates your dopamine system even before you swallow the first bite from the mouth. You feel sugar, you get a dopamine boost. It's highly addictive. It's a great example. I like donuts, but just so you know, we are addicted beings. We're just a matter of what addiction you prefer. And I vote for healthier ones. But just so you know, it's not just drugs. And here is a comparison of the compound we just talked about, GAC, and endorphin. And those endorphins, which also called endocannabinoids, are what actually meant to activate those receptors and block GABA neurons. So it's in interneurons which control and keep serotonin and dopamine in bay without going too crazy. But once they are blocked, then a lot of good things happen. And interestingly, it's also a natural painkiller. So I'm jumping a little bit ahead, but endorphins are released when we exercise. And we usually don't feel muscle pain until the next day. And then everything hurts. That's the reason we actually get anesthesia during exercise to keep us going. And then in 1-2 days, you're like, oh my God, everything hurts. That's why we can run, dance, and do lots of activities for hours without noticing being tired. On this optimistic note, I would like to switch to exercise. And I want to start with this person. So some people would ask if running causes release of the same chemicals, is it addictive? Well, in some cases, it seems like it. 50 marathons in 50 days. This person runs the longest distance non-stop, and he's running about 20 miles a day. I've read an interview with him. He's completely normal dad. He has a job. He wakes up at 3 a.m. in the morning to do his exercise routine, and then he takes his kids to school. He works in a financial company. He's not an addict in any kind of way. But you will probably be thinking, I'm not like him. I don't actually like running. Me too. I don't like running. So if you don't like running, you can pick up another activity. But according to studies which I read, heartbeat is very important in order to release endorphins. It's about 150 beats per minute. Depends on the person's size, but it has to be between 50 and 80% of your maximum heart rate. So you can calculate it online and find out which heart rate gives you this a boost of endorphins. And I list some of their activities which were tested most of the time. And it seems like jumping rope is very effective. It's more effective than running. So if you don't have time and you don't like running, you can do jump rope for 10-15 minutes. It produces very similar effect on the heart rate and endorphins release. Additionally, there was multiple studies where people suggested that the rising body temperature is what causing the high. Because swimmers don't have a high, but runners do. So what's the deal? And some people tested that there is a skin receptors, thermo-skin receptors. Huh? Do you feel high? See? Try jumper. Interestingly, when they study the body temperature and the skin temperature, they found that there is receptors which get activated when the body temperature goes up. First of all, it helps people to survive when they're sick and feel better. But also, it explains why so many people like to go to sauna and jacuzzi. Because sauna and jacuzzi relaxes a lot of people, and apparently it's because there are serotonergic neurons which are getting activated and release additional serotonin into the brain. So if you are a huge opponent of any exercise, jacuzzi will help to a certain extent. Now I want to go back to the very first simplified version which I had for you and add exercise to it. What's BDNF? Well, it goes for brain-derived neurotrophic factor. it's not a neurotransmitter, it's a promoter. It stimulates growth of neurons, which leads to neuroplasticity. So when they found that exercise boosts this promoter, they found that brains start growing when you exercise. And now I want to go back to depression. Remember I told you that so many people taking antidepressants for more than 2 years? So I want to go back to it and re-evaluate what's going on there. This is a network hypothesis of depression. And what it shows here, that's a healthy person, and when person is in depression, what's happening is neuronal connections getting destroyed and distorted. And normal neuronal circulation is changing. Once person starts taking antidepressants, it raises serotonin level, and serotonin level increases brain-derived neurotrophic factor, and it's increased neuronal plasticity. So what happened afterwards is activity-dependent pruning and stabilization of network. So it's too expensive for the brain to maintain all of those contacts. It's too much energy. So contacts will be shrinked. And only those which are active and maintain regular activity will be saved. And what's not used will be eliminated. So if person is taking antidepressant, restoring the network, but not using it, they're going to, let me see. They're going to go back to this stage. They have to start using their brain. So, fun fact. This guy. Have you heard this phrase that C squared is his brain? Technically, it doesn't. But the larva is swimming, and it has a nice brain. Once it settles on the rock, it turns into adult form. Tunicates, we've had them in the aquarium. Maybe you might recall those squirt animals. You squeeze them and they spray salt water on you. That's an adult form, and a larva is actually reminds fish a little bit. So when they transform through morphogenesis, brain degrades. And the reason it degrades is because once it's settled, it doesn't need so much complicated machinery. It's trying to save energy. So if we go back here, similar idea. If you're not using it, you're losing it. That's why therapy for depression, which involves some sort of creativity, exercise, and something which involves active brain work, it's very much more effective than antidepressants on its own. So the reason those people are staying on antidepressants for so long is because they're not using other alternatives to help fight the depression. Oh, okay. Am I going so fast? Okay. I have some extra slides, but for now, I would like to open up the floor for any questions you have. I will repeat the questions if you can hear it.